Welcome to the first video in the Electricity and Magnetism unit. Today we're going to introduce the concept of electric fields. So, what is a field? The term field was first used in physics in 1849 by Michael Faraday. Faraday is a famous physicist who invented the electric motor, made the first generator, and discovered benzene. He came up with the laws of induction and electrolysis, which are still used today. But what is a field? The Encyclopedia Britannica says, field, in physics, a region in which each point is affected by a force. But what does this mean? Maybe the best way to understand a field is with an example you're familiar with: gravity. A gravitational field is a region in which an object with mass experiences a force, and this force can cause objects to accelerate. It's the same gravitational field that keeps you, an object with mass, firmly attached to the Earth's surface. So that's a gravitational field. What's that got to do with an electric field? Well, an electric field in physics, well, it's also a region in space. But this time, it's a region in space where a charged object experiences a force. And this force can cause charged objects to accelerate. Okay, so what's an electric charge? Electric charge is a physical property of matter. It causes that matter to experience a force when it's close to other electrically charged matter. You probably already know that there's two types of charge. There's positive charge, like that on protons, and then there's negative charge, like the charge on electrons. Unlike charges, like this positive charge and this negative charge, they cause a force of attraction on one another. It's this force of attraction that keep electrons in orbit around the nucleus of atoms. If this force didn't exist, then atoms as we know it wouldn't exist. And like charges, like these two positive charges, they are repelled by one another. And the same thing happens if we have two negative charges. They are also repelled by one another. Unlike charges attract, and like charges repel. Charge has the symbol little q or big Q, and is measured in Coulomb, capital C, after the French physicist Charles Augustin de Coulomb. Coulomb, among other things, helped develop the SI units that we use in physics. He was so amazing that his name was inscribed on the Eiffel Tower when it was constructed. The charge of an electron is negative 1.6 times 10 to the power of negative 19 Coulomb. This means you need about 6 times 10 to the 8 electrons to get a charge of 1 Coulomb. That's a lot of electrons. An interesting thing about electric fields is that you can't see them. You can only see their effects. Even though you can't see them, we can represent them by drawing field lines. The closer together field lines are, the stronger the force on a charged particle. That means this electric field is stronger than this electric field. So if there's a charged particle in the electric field, it will experience a greater force in this field than it will in this field, assuming they have the same charge. Field lines have a direction. Their direction is in the same direction as the force on a positive charge, because positive charges are repelled by other positive charges, like positive charges on a flat metal plate, and they are attracted to negative charges, say the negative charges on this flat metal plate. Field lines always go from positive to negative. The direction of field lines is represented with these arrows. Now, another thing about field lines, we'll take these ones this time. Field lines, they can never cross one another. For example, this field line cannot cross any other field lines. Can you think of a reason why that might be? The final rule for drawing field lines is that they always intersect conducting surfaces at right angles. For example, if I extend these ones back to this conducting plate, you can see that they are at right angles to the plate. At this end, where they intersect this conducting plate, they are also drawn at right angles. Here's some pictures of some field lines around different charged objects. Look out for the 4 rules. The closer together the field lines are, the stronger the electric field is. That field lines are always marked with a direction. That direction is the direction that a positive charge would move in the field. So away from positive object towards negative objects. The field lines, they never cross. And finally, the 4th rule, field lines always intersect conducting surfaces at right angles. That's it for today. So let's recap. An electric field is a region in space where charged objects experience a force. Charge, which has the symbol little q or big Q, is measured in coulomb, and the units have the symbol big C. You can't see electric fields, you can only see their effect. And we use field lines, like these ones, to represent the strength of electric fields, strong over here, and weak over here. And also, we can use arrows to show their direction. In class, we're going to use some seeds and oil to observe the effects of field lines. Don't forget to write down questions and review this video, and check out the links below for an interactive simulation so you can experience the force on charged particles when they are in electric fields. Cheers.